Hey guys, this video, I'm doing this live because I want you to see my calculator display. We're talking about laws of logarithms. So on the side here, you'll see that I have log base 10 of 10 equals, and then I don't have anything. Well, I just wanted to remind you that your calculator has a button on it that says log, and it is log base 10. So I never have to tell the calculator what base I'm using as long as the base is 10. But I want you to kind of get an idea what a log is actually doing for you. So I'm going to do log of 10. And every time I hit the log key, I get a parenthesis. It's just bad habit to leave it open. So I'm going to close it even though it won't change my answer. And my calculator is going to tell me the answer is 1. My answer is 1. Now, I'm going to do it again. I'm going to do log base 10, but this time I'm going to take the log of 100. Now, my calculator is about to tell me the answer is 2. Since my calculator is programmed to understand base 10, I don't have to do any fancy switcheroo with anything, but can you guess what the log of 1,000 is going to be? Well, 1,000, if you've guessed the answer is going to be 3, you're correct. Now, there's patterns in mathematics all over the place. So log of 10, guess what? There's 1 0 in a 10. There's 2 zeros in a 100, 3 in there. So guess what? This one has 4 zeros, so chances are the answer is 4. And yes, long and short of it, that is exactly how this works. But here's why we started this chapter with exponential information. See, here's what a log is actually doing. When somebody says log base 10 of 10, what your calculator's doing is an exponential thinking process in reverse. The base is 10. So it's saying, this is what your calculator's doing. 10 to what power will give me 10? Well, what's the answer? It's 1. Then on this question right here, what is it doing? The base is 10. So your calculator is saying 10 to what power will give me 100? And then, of course, what's your calculator going to say? Well, it's power of 2. So a log is actually related to an exponential concept. And since all the sciences, like scientific notation, is base 10, you know, you'll see in a science book 3.2 times 10 to the 6th, or 10 to the negative 6th, for that matter. Scientific notation is all base 10, so logarithms are all base 10. Whoops, my calc went dim. So, the thing is, I can trick my calculator into doing any base I want. In fact, I showed you that in the graphing video, but I did not explain anything like why does it work, what's it doing, etc. So let's just kind of play with this for a second. Let's suppose I said, what is the log base 2 of 8? Now, my calculator does not understand base 2. I have to trick my calculator into understanding base 2. But think about it. You could do this in your head because this one is one of those times where your answer is going to turn out to be a pretty number. So think about it. What's the base? The base is 2. Your calculator is saying 2 to what power is going to give me 8. So think about it. 2 squared is 4. 2 to the third is, there it is. So the answer your calculator is going to tell you is 3. How do I trick my calculator into doing that? Well, I do it this way. I do log of the number I want. I want the log of 8. But I'm going to divide by log of 2 because I want to trick my calculator into thinking it's base 2 and not base 10. What do I get? 3, just like I thought I would. Because Logs are technically asking this question in reverse. So that is what the thought process is for a logarithm. So if I asked you, what do you think the log base 2 of 32 is? And then you'd say, well, the calculator is doing this. It's saying the base is 2, and it's going to take it to some power and get 32 for an answer. Now, you could guess and check, and say, oh, the answer's 5, or you trick your calculator and you say, I want to know what the log of 32 is, and I close the parentheses, divided by log 2. And then my calculator does the hard work for me, and I don't have to think about it. The answer's 5. Now, some people always come up to me every year and go, you know, there's a way to punch it in so it looks just like this. And I go, yes, I know, there is a way to do that. But in my book, it's actually more work. I think it's kind of a pain in the butt. But here we go. I'm going to show you it anyway. There's a key right here that says alpha. If you do alpha window, you'll see this thing come up and look, log base. Log base. See, now look at how it presents the problem. So if I wanted to, I could do log base 2 of 32 that way, and guess what? It's going to tell me it's 5. So if you want to, you can go alpha window, and then you'd have to choose this thing called log base. And I could do, what is the log base? Oh, I don't know, 5 of 625. Log base, whoops, I do that a lot. Oops, hang on, let me delete that, because I didn't mean to, I meant to put it up in the thing. Log base 5, and I forgot to do side arrow, of 625. Well, that's 4. Everybody knows that's a fancy way to say 4. Or you don't know that. But you could also do log of 625 divided by log of 5 and trick your calculator into thinking its base is 5. And guess what? You'd still get 4. But what does it really mean? What does it really mean when I do log base 5 of 625? It means 5 to some power will give me 625. That's what it means. And what is that power? Well, I could guess and check, or I let my calculator tell me what it is by using the log button. Now, this information about how we can mess with logs and stuff, oh, there are so many different things we can do. So this lesson is about one specific trick you can do, which is called the laws of logarithms. So here we go. The laws of logarithms, there's 3 of them. So here we go. The first law is called the product rule. So we have laws of logs. The first one is called the product rule. Now, on your calculator, if you wanted to, you could punch in base, any base you want, right? You can use any base you need to. But to make to make this run smoother, I'm just going to do everything base 10. And then in my next video, I'll start messing with different bases. But just so I can show you quickly, everything's going to be base 10, which means I will not be writing in a little 10 there. If it's base 10, my calculator already knows it, and it just calls it, log. Okay? So I'm not going to be writing the 10 in next time. But if I wanted to do, let's say, the log of 10, or log base 10 of, let's try 12. Now, the log base 10 of 12 is a weird number. It's going to give me a super decimal. That's what I call them. So if I punch this in on my calculator and I say log of 12, it's base 10, I'm going to get this weirdo decimal. Okay, that's a fine answer. It's okay. But here's what the product rule says. The product rule says if you want, you could express this any way you want. I'm not going to write the base of 10, but Do you agree with me that 12 is the same as 2 times 6? Do you agree with me that 12 is the same as 3 times 4? Okay, well, here's what's weird about logs. When you mess with a log, you can separate the statement like this. The log of 12 is equivalent to the log of 2 times 6. It is. It is. Look, here, I could do it this. I could. Log parentheses 2 times 6. I get the same answer. Look, log of parentheses 3 times 4. I get the same answer every time. But here's the weird thing about logs. Check this out. This is called the product rule. If you can write it like a product, then you can write it like this. The log of 2 plus the log of 6 will also be that answer. Right here, the log of 3 plus the log of 4 will also be that same answer. Check this out. Check this weird thing out. I'm just going to do it here. Log of 2, close the parenthesis, plus log of 6. Guess what? It's going to give me 1.07 blah, blah, blah. There it is. See, let's try it again with the 3 and the 4. So I go log of 3, close the parenthesis, plus log of 4, close the parenthesis. Guess what? Same darn answer every time. There it is. The product rule. So I'm gonna illustrate this. The product rule says, and this is how it's written in our book, logaxi. Logaxi. No, this is log base A of 2 things being multiplied, an x and a y. So in our book it says this. If you take the log of 2 things that are being multiplied, doesn't matter what base it is, could be any base you want it to be, any base. It's the same as log of the first guy plus log of the second guy. That's the product rule. So like here, I started with the log of 12. I wrote it as 2 times 6, which means I could write it as a separate log of 2 plus log of 6. I would still get the same answer. Here I did it as 3 times 4, but I could do it as log 3 plus log 4. I get the same darn answer. So this is called the product rule. So what you're going to see is I am not going to write any base in here. And I'm going to do something like this. Log of 3x. So what does that mean? It means I could write this as the log of 3 plus the log of x. I could. That's what it means, because these guys are being multiplied together. So for the rest of this lesson, I don't really need the calculator. I could show you different ways that things are true, but you know what? I'm going to put this aside, and I'm just going to say, let's just talk about the rules now. So, what if this was a base 6? Well, then I'd have to put a base 6 here and a base 6 here. That would be the only difference. So, the product rule. The product rule, log base 10. I'm going to use base 10 on all my assignments that I give you so I don't have to keep writing a base in. But what if they did something like this? 5xy. Well, all that means is I have log of 5 plus log of x plus log of y, because I have 3 things being multiplied together now. That would be what we call my expansion. That's my answer. What if they gave me this as a log base 2? Then I'd have to put a little tiny 2 right here for the other ones. That would be the way it works. Product. You can write any product as the sum of the components, whatever they happen to be. That's all I did. That's called the product rule. Now, let's talk about the next one. This one's called the quotient. The quotient is very similar. In our book, they say log base A, so it could be any base number they want. And then they do this. They say, what if we have something divided by something else? Log base A of x divided by y. Well, guess what? The answer would be this guy minus this guy. It is totally true. It is totally true. For example, if I wanted to punch in the log base 10 of the number 6. I could do that on my calculator. I'm going to get a weird number. But I could also say, you know what? Log of 6 could be the same thing as log of 12 divided by 2. Yeah, because that's 6. So what does the quotient rule actually say about something like this? Well, if I wanted to, I could punch it into my calculator like log of 12 minus log of 2. And I will get the same weird super decimal for all three statements because the quotient rule says division of two things is the same as subtraction. So if they gave me something like this, what if they said log of 8 divided by A, right? Well, I could rewrite that as the log of 8 minus the log of A. What if they gave me this whole question and they said it's base 3? Well, then I'd have to put a little tiny 3 here and a little tiny 3 here. That would be it. Now, I got one more law of logarithms. The last law of logarithms is the most useful when we get into next week. Not this week, but when we get into next week's stuff, this thing is the most useful of all three of these properties. It says this, and it looks weird. If you take the log base anything, any base you want to use, of something that has a power on it, then it's the same as bringing that power down. It's the same as multiplying that log by that power. So if you take the log, any base you want, of something to a power, it's equal to taking the power and multiplying it by that log. Plogax is not how you would say that in mathematics. Kids would laugh at you at math camp if you said plogax. But let me explain what this thing is doing. If I took the log, and I'm going to use base 10 because I'm going to do this on my calculator. I took the log of 5 squared. Well, that's the same as taking the log of 25, right? I could if I want, because 5 squared. So, clear. If I do the log of 25, I know I'm going to get a weirdo number, okay? But this is the log of some number to a power, right? Log 25. Well, guess what? This rule says if you want, you could bring the 2 down in front, and this will be the same thing as 2 times the log of 5. That's what that, so let's see. 2 times the log of 5. What's my answer? It's the same damn thing. Oops, I said damn. Darn. Okay. Let's try that again. How about if I give you like the log of 3 to the 7th power? Well, 3 to the 7th power is a weird number. What's 3 to the 7th? I don't know. 2,187. Okay, so if I did the log of 2,187, I am going to get this weird decimal. But what does that mean? It means if I wanted to, I could punch this into my calculator like this. 7 times the log of 3. I could do 7 times the log of 3. And what will I get? That guy again. This is called the power rule. So, here's the thing. These questions you're about to do are going to look like this. They might give me something like this. Log 5x squared over y. And you look at that and you go, oh man, that looks like a pain. I don't know what to do. Here's the thing. I did not tell you this at the beginning of this recording, but this guy right here, that could be written like this. Log of 5 plus the log of x squared minus the log of y. I could do that because that's a product, that's a power, and that's a quotient. The three rules that we're talking about are product, quotient, and power. And those three rules, they all exist together. Now this one is technically not finished yet. I didn't completely finish that question because I could bring the 2 down. So the final answer for this question would be log 5 plus 2 log x minus log y. This is called an expansion. So if I give you something, you should be able to expand it. And then if I give you something expanded, you should be able to write it as a single log. So what we do in math a lot of the time is we have a way to go this way and we have a way to come back. So you can either expand a log or you can write it as a single log. You can go from here to here or from here back to there. And that's what this video lesson is all about. The explanation to do it right takes longer than it does to do it. You might actually finish this assignment in 10 minutes. I don't know. Everybody's different, but let's take a look. I'm gonna go through another one. What if they gave me something like this? Log of x to the 4th over y to the 5th. And just for kicks, since I haven't done this, I'm going to put this in parentheses so you know the whole thing is being taken log base 7. I'm going to put a 7 there. Now, I didn't do this on the assignment, but I figure what the heck, it's a teachable moment. If this is a log base 7, I have a power, and I have a quotient. I do not have a product here. So if I was going to expand this, how would I do it? I would write log base 7 of x to the 4th minus log base 7 of y to the 5th. And then I would drop it like it's hot, drop it like it's hot. And I would put those in front, and I would say this is the same as 4 log base 7 of x minus 5 log base 7 of y. And there's my expansion for that statement. So what you're going to see is a lot of different questions like this. Now, let's just play a little bit more. And then we'll get to the work. But what if they gave me log, and I'm going to leave it base 10 because I don't want mess. And they gave me something like this. 6x 4th y 2nd. Well, guess what? There is no quotient this time. I didn't put a quotient in here. This is just product rule, so I could say this is all multiplied. So log 6 plus log x to the 4th plus log y squared. But we're not done until we bring the power down. When you write an expansion using logarithms, you're supposed to employ every single trick you have. So my final answer would look like this. Log 6 plus 4 log x plus 2 log y. And that is called the expansion of the original problem. Now, I can go backwards. Let's play the backwards game. Whoop. I don't know why my alarm is going off, but I'm going to turn it off. Okay. So we'll play the backwards game just a couple times, and then we'll get moving here. So what if I gave you a statement that said log of 4 plus 3 log x minus 5 log 7. Well, guess what? I would not want to drop it like it's hot. I would want to pick it up like it's cold if I was going to try to make it into single log form. So my first step would be start undoing things. I would bring the 3 back up here. I would bring the 5 back up here. That'd be my first step. I'd undo the power. Now I'd look at it and say, that's a product. That is a quotient. So I could now write this as a single log. And I could say log 4x third. There's my product. Divided by, there's my quotient, 7 to the 5th. And this would be called single log form. So on the assignment that you guys are going to do for me, you're going to practice going from expanded to single, single to expanded. You're going to go forwards and backwards. Let's just do one more, and you're going to see why I'm going to stop this video now. I'm going to do log base 10, just what the heck, of cube root of x squared y over the 4th root of z. Nah, what the heck? Z to the 5th. Now you're going, oh, that looks super bad. Okay, so guess what, guys? This is why this video is going to end right now, because this is going to be in part B. This is my next video, and that way I can do it on the whiteboard, or and I don't have to do this live with the video. Okay, so this one's done. The assignment for this, you will find it in the next video.